It's April 10th, 1815, and in just a few moments, the sun is going to disappear. On an island in present-day Indonesia, Mount Tambora erupts with a boom that can be heard over 2,000 kilometers away. Sulfurous plumes of steam and ash billow thousands of meters into the sky, forming dark storm clouds of soot and lightning. This eruption will go down as the largest in recorded history, but at this point, its impact is only just beginning. Ascending high into the atmosphere, Tambora's emissions spread across the globe, blotting out the sun for almost an entire year. The hazy skies and cold weather of 1816 wreak havoc on agriculture, leading to famines all across the northern hemisphere. Nations struggle with epidemics, and artists craft bleak tributes to these seemingly apocalyptic times. This was the year without summer, literally one of the darkest periods in human history. So why are some modern researchers looking for ways to repeat it? Obviously, no one wants to replicate this period's famine and despair, but some scientists are interested in using sulfurous haze to block out the sun and hopefully slow the effects of global warming. This is one of many proposals in the realm of geoengineering, a class of deliberate, large-scale interventions in Earth's natural systems, intended to help restrain climate change. Different geoengineering schemes intervene in different systems. Any plans to cool the planet by blocking the amount of sunlight reaching the Earth would fall in the category of solar radiation management. Some of these proposals are massive in scale, such as suggestions to create a helpful version of volcanic plumes, or build a giant sunshade in Earth's orbit. Others are more limited, focusing on enhancing natural cooling systems. For example, researchers might enlarge marine clouds, or make Earth reflect more sunlight by building huge swaths of white surfaces. Many of these plans sound more than a little strange, but there is reason to believe they might work, not least because of natural events like the eruption of Tambora. Scientists know that volcanic eruptions have periodically cooled the climate. Both the Pinatubo eruption in 1991 and 1883's blast of Krakatoa reduced global average temperatures by at least half a degree Celsius for up to a year. These cooling effects are global and fast-acting, but they're also incredibly risky. The Earth is a chaotic system where even the smallest changes can create countless unpredictable ripple effects. We know that cooling temperatures impacts precipitation, extreme weather, and other climate phenomena, but it's difficult for even the most advanced computer models to predict how or where these consequences will occur. One country's solar radiation management might be another country's unnatural disaster, causing extreme weather or crop failures like those following Tambora's eruption. And even if these schemes did safely cool the planet, solar radiation management doesn't address the greenhouse gases that are causing global warming. These solutions are just highly experimental band-aids that the world would have to endure for at least a few decades while we work on actually removing CO2 from the air. And if we pulled that band-aid off prematurely, global temperatures could rapidly rebound, causing a period of intense superwarming. For these reasons and more, solar radiation management is risky. Today, researchers are running small-scale experiments, such as enhancing marine clouds to protect the Great Barrier Reef from further heating and bleaching. And most scientists agree that we should pursue ways to cut emissions and remove atmospheric CO2 first and foremost. However, there are reasons to keep studying these more aggressive approaches. Desperate times call for desperate measures, and in the future, geoengineering might be civilization's last resort. Furthermore, some of these plans would be shockingly easy to execute by some rogue actor with enough cash. So we'll want to be prepared if someone starts geoengineering without governmental approval. But perhaps the most important reason to investigate the impacts of geoengineering is that people are already making large-scale interventions in the atmosphere. In many ways, climate change is an unintended geoengineering project, fueled by the emissions generated from centuries of burning fossil fuels. And unless we take action to curb emissions and draw CO2 out of the atmosphere soon, summer may never be the same again. For a smaller scale approach to preserving our planet, learn how to waste less food with this video. And visit ed.ted.com/earthschool for an action guide that breaks down the most impactful steps you can take to help cut carbon emissions.